Welcome back, you guys. We're going to be in Forces in Motion Lesson 2.1, exploring mass, forces, and velocity. Let's go ahead and start out with your warm-up today. So we have a letter from Anna Gonzalez. She is sending this to us as physicists, and she says, "Thank you for sharing your models and explanations. This information is very helpful. We analyzed the thruster data from the pod and found that the thrusters exerted the same strength force as the other missions. Since this pod didn't stop, we'll need to look at another cause. The pod had been collecting asteroid samples, and we're not sure how many it was carrying. Could a difference in the number of asteroid samples explain why the same thruster force caused a different change in velocity? We'd really appreciate your help with this. Dr. Anna Gonzalez at the Science Program." Okay, so underneath this, I just want you guys to hop in and answer this question. Do you think the number of asteroid samples in the pod, or that the pod is carrying, makes a difference? Might it explain why the same thruster force caused the pod to move a different or change in velocity? Explain your ideas even if you're unsure. So pause the video here and take 2 minutes to answer the warm-up question. Set a timer. You can just open one up on Google. 2 minutes, pause the video here, complete your warm-up. All right, so the chapter 2 question we're going to be focusing on is that the thrusters on the ACM pod exerted the same strength force as the thrusters on the other pod. So why did this pod move differently? Well, remember, we're not sure how many asteroids the pod was carrying. So from your warm-up question, do you think the number of asteroids could actually make a difference? Why or why not? Pause the video here and talk with your shoulder partner for 30 seconds. Go. All right, we're going to go on to activity 2, investigating forces on different objects. So today we're going to investigate the question of, if the same strength force is exerted on two objects, why might they be affected differently? So you're going to plan and conduct an investigation to help answer this question. Your results will help you explain what might have happened to this pod. So if this ball were sitting on a table, how could we make it move? Absolutely, give it a force. First, you're going to plan the investigations thinking about how you would use the launcher to exert the same strength force to see how it affects both the table tennis and the golf ball. So you want to put the same force on each one and see how it affects what happens to them. So we're going to jump into Amplify and go to Part 2, Card 1. And in Part 2, Card 1, you're going to go through some questions here. I'm going to go through them with you on the slide. So what will you change, and what is your independent variable in each test? So what you change, or what I, notice the independent starts with an I, what I change in each test is going to be your independent variable. So what are you going to change? What will you observe? So what's going to change as a result of what you change? So what I changed is independent. What happens because of it is the dependent variable. All right, so what is going to change because of it is going to be your velocity, absolutely. Okay, so if each object starts at rest, then its initial velocity is going to be 0. This means that the object's change in velocity is going to start at 0 and go up to whatever number you are. So that's going to be its final velocity because it wasn't moving when you first started it. So remember, velocity is the speed in a particular direction. So you'll need to find the speed and indicate the direction and calculate the velocity. So velocity is calculated as a distance over a time. So all you need to do is, let's say our distance is, I'm going to put an equal sign here. Let's say our distance is 20. That looks terrible, but that's okay. 20 meters, okay? And our time is 20 seconds, okay? Then our velocity would be simply 20 divided by 20, which any number divided by itself is always 1, meters per second, and that would be our speed. Okay, now to make this a velocity, I'm going to need to add a direction. So we want to say that it's going to the right. Or we could even say that it's going north. Okay, or we can put an N there instead. So that's how we calculate velocity, the distance divided by the time. As simple as that. All right, so now you're going to plan your investigation. So you need to come up with the steps that you're going to do and describe the steps you're going to take in your investigation and create a data table that will record your results. So now that you have already gone over, since we went over them, what do you think that your independent variable and dependent variable is? Don't forget to answer this question. Why might the objects be differently affected even though they have the same force exerted on them? What tools do you need to measure it, and what will you keep controlled every time? And how many tests do you think you should conduct and why? We've talked about a number you should at least do, so maybe that would be a good number, and tell us why. Okay, so you're going to pick up the golf ball and the table tennis ball and compare the two objects. And you're going to tell me, is the golf ball or the table tennis ball lighter or heavier? Then you're going to work with a partner and come up with those steps we were just discussing. And you're going to create a data table to record your results. So depending on what you guys decide you want to do, you'll write your steps out here for what you're going to do for your activity. So you're going to be writing your own experiment. On the bottom part down here is your data table. So this is where you're going to fill in the information that you are going to be recording. I would suggest putting like golf ball and ping pong ball or table tennis ball here, and then what are you going to record here? And then after you're done, analyze your data. So look back at the data that you just collected and what do you notice is happening? What are some patterns that you see? Why might these two objects be affected differently if the same strength force is exerted on them? All right, so remember you want to hold that spring launcher flat on the table with one hand and pull the narrow back end back so that you can launch. Okay, the stopwatch must start the time as the launcher is released, and you and your partner are going to need to work together to make sure that you accurately record that time. Complete your investigations and record your results, then answer the questions about what you observed that we just discussed, and then pause the video here so you can go ahead and complete part 2 of lesson 2.1 and card 2. All right, welcome back. What did you observe in your investigations? Pause the video here, take a moment and discuss this with your partners. You should take 30 seconds. Go. All right, welcome back again. So we have a vocabulary word, which is mass. The amount of matter that makes up an object. So mass is the amount of matter that makes up any object. Okay, so which object would have a greater chance in change in velocity if you exerted the same force on each of them? A toy car or a full-size car? Absolutely, a toy car. Okay, so which pod would have a greater change in velocity if you exerted the same strength force? A less massive pod, meaning it has less asteroids in it, or a more massive pod, meaning it has more asteroids in it? All right, hope you guys got that one. All right, we're going to move on to activity 3, investigating force and mass. So next we're going to use the sim to continue to gather our information and evidence to answer the question of, if the same strength force is exerted on two objects, why might they be affected differently? So the sim investigation has two parts. In part 1, you're going to investigate how the same strength force affects objects of different mass that are not moving. So they're starting out at 0. In part 2, you'll investigate how the same strength force affects objects of different mass that are already in motion or already moving. So in the analysis mode, when you click Analyze of the sim, you can observe the exact change in velocity. So it's going to tell you how much the velocity changed right here. Okay, so you're going to hop back into your lesson and go ahead and get started on the part 3 sim. You'll click on your sim here. Okay, so from the sim, we're going to select 2.1 motionless object. So you should be doing this right along with me. 2.1 motionless object. The directions then say press run, then press play to begin. Observe the initial velocity of the objects and then press prepare force to pause the sim while you set up your forces in your data table. Okay, so you're going to press run and then you're going to see what happens. They're absolutely not moving. So if we notice, all of our initial velocities will be 0. Use the arrows in the force panel at the bottom right corner to set up the force on object A. So object A should have a mass of 0.5 grams. We want to give it 4 clicks to the right. So we're going to click on that object and we're going to make it go 4 clicks to the right by hitting prepare force. We're going to choose object A. We're going to click 1, 2, 3, 4 to the right. Okay. Then it says to select object B and put a force in the force panel to use the arrows set up the force for object B, C, and D. So we need 4 clicks to the right for all of them. So we're going to click on each one. You can also click on them down here at the bottom corner, 1, 2, 3, 4, and D, 1, 2, 3, 4, okay? And then what you're going to do is it says press exert the force and see how the observe how the velocity changes, press analyze, and record each object's change in velocity and then respond to your questions. So you need to record each one of those here and then tell me which one of those changed the most, okay? Pause the video here so you can complete card 1. You should take no longer than about 3 minutes to complete this and record your data and answer this question. So let's think back to that pod. If the thruster's force was the same as it always is for the ACM pods, why do you think this pod's motion was different? Pause the video here, discuss that with your group for 30 seconds, go. All right, welcome back. The pod's mass might have actually been different because it collected a different amount of asteroids. So remember that these two claims are the ones that we had about the pod. You will discuss this claim with your partner and see which one you think it is now. Normally when the thrusters fire, the pod will stop, but this mission was actually different. If the thrusters on the pod exerted the same strength of force as the thrusters on the other pods, what else might explain why it moved in the opposite direction? If you're looking at claim 2, if the thrusters on this pod exerted the same strength force as the thrusters on other pods, then what else might explain why it crashed into the space station? Okay, before we end this lesson, we're going to do one last part. So if you go back to Amplify and click on part 2, you're going to go back to 2.1 and do moving objects this time. So we're going to click over here. You should be doing this right along with me. We're going to click 2.1 moving objects. Then it tells us to do the same thing. We're going to hit run, press play to begin, observe their initial velocities, hit prepare force, and set up 4 clicks to the right for each one of those objects. You're going to do the exact same thing. So go back, hit run, then watch what they're doing. Okay, they're all moving at about the same velocity. So then we're going to go back and we're going to exert the 4 clicks on the right to each one of these. Then what you're going to do after you're done with that, record your data here and decide which one of those changed the most. So pause the video here, take no more than 3 minutes to do this, and then come back to the video. All right, so that's the end of the lesson. Please make sure you go back and check your key concepts and complete your mastery check if this is the end of the 2 lessons where you can complete your mastery check, and then hop back into Canvas, see if there's anything else that you guys need to complete for today, and have a wonderful day.